Good morning, everyone, and happy National Engineers Week from our team here at West Virginia American Water. And we are so excited to be back with you again this year, grades 6 through 12 in all 55 counties across West Virginia. We are live doing our Engineering in the Classroom virtual education webinar, and we have members of our engineering team who are going to be giving you an overview of what they do here at West Virginia American Water and kind of their pathway to their career as an engineer. And we also have with us today Erica with the West Virginia Department of Education. She heads up all the STEAM education for the state of West Virginia. We're so thrilled to have her with us and for the partnership that we've built with her and the Department of Education over the past couple years. And before we turn over to Erica, I just wanted to share a proclamation from Governor Justice proclaiming this week National Engineers Week in West Virginia. So we appreciate the support of the governor and really appreciate putting some special attention on our engineers this week, but we like to put attention on them every week as they are so important to our operations here at West Virginia American Water. And without further ado, I will turn it over to Erica. Erica's with the West Virginia Department of Education, and I'd like to turn it over to her, say a few words about our partnership and about this engineering in the classroom that we started.
Well, thank you, Bradley, and thank you to West Virginia American Water for providing this opportunity for our students. I'm Erica Close, and I coordinate science and computer science and STEM along with a few other things, but I have a tremendous opportunity on a daily basis to work with our educators throughout the state to have our students have better access to amazing careers, such as a career as an engineer. So we are very thankful to West Virginia American Water for providing this opportunity for students to get a glimpse into what engineers do every day. If I could share any bit of encouragement to our educators and to our students, I would just ask everyone to listen carefully to what's shared about what is best for you to do in middle school and high school as you prepare for your career. You know, once you leave K-12 education and you head out into college or into the career world, it always gets a little more challenging to learn. And when you are in a high school with educators who are interested in providing you tremendous opportunities, you are in a very, very supportive environment. So I just want to say, you know, take the hard classes now. Take chemistry now, take physics now. You'll probably end up taking them again in college, but take them now when you have an educator that is there just for you, supporting you, has been with you for a long time with groups of students that will also support each other. So I just wanted to say, please, educators, encourage your students to, take as much science and math that they can now while they're still in high school and get some of that done before college and lay a strong foundation for whatever their future might be. All right, that's my little take the hard classes soapbox for right now. And I just say again, thank you to West Virginia American Water, and I will turn it back over to Bradley.
Thank you, Erica, and we are so thankful for the West Virginia Department of Education, and really we fostered our relationship and our partnership to make sure that we are educating. This is our next generation of leaders, and it's so important to shed light on engineering careers in the water and wastewater industry, which is what we're going to do today with Mike, who's our Director of Engineering. And so before I turn it over to him, I do want to remind you we have question and answers along the right side of the screen. There's an icon at the top. And you can click there and you can put your question. Let us know where you're tuning in from. Let us know what school, what county, what classroom, who your teacher is if you're part of a classroom, and we will be screening those throughout the presentation. So again, want this to be as interactive as possible and get as much information to you as we can in the next 25 minutes. And so without further ado, I will hand it over to Mike Ramo, who is our engineering director here at West Virginia American Water. Mike, thanks so much for being part of this today.
My pleasure, Bradley. Thank you, all of you tuning in today for the opportunity to come into your classroom and speak. Thanks to Miss Erica for basically giving a pitch for do hard things. I love it. The final thank you goes to Rich. I'll call him my technology engineer who's running the slides and all the video production here for us today. So I just want to take, at least 20 minutes here and kind of go through what you see on the screen here as far as a little about engineering, how to be an engineer, how to become an engineer, and what specifically is civil engineering, and how does West Virginia American Water play into that. So next slide, please, Rich. So a little bit about myself. You see that up there, as Bradley mentioned, I'm in the engineering department of West Virginia American Water. West Virginia American Water is a company, a water company and wastewater company of about 315 professionals that work day in and day out, whether they're a utility worker, an operator, we have accountants, we have engineers, just other professionals that bring safe, clean, reliable water to about 560,000 West Virginians. That's about a third of the state drinks water that has been treated and cleaned, delivered by West Virginia American Water. In our company alone, we have about 4,600 miles of water pipe that brings that drinking water all across the state. So what does 4,600 miles look like? Well, if you were to drive from New York to Los Angeles, turn around, and then drive back to St. Louis in the middle of the country, that would be about 4,600 miles. That's the same distance of pipe that we have in the ground, again, to bring clean drinking water to homes across the state. You see, I went to college a couple times for civil engineering. I also was in the Army for 8 years. And whenever I have the opportunity to talk to young people, I do like to put a plug in for the military. The military is not for everybody, and I recognize that. But if you are curious, if you are wanting to serve something that's bigger than yourself, I would ask you to consider the military. You know, for me, it was the Army. The Army paid for my college. I did have to spend another 5, 6, 7, 8 years in the military, kind of to pay them back for paying for my college. But that is a great opportunity where you get an education, you get specific training. I went all over the world with the Army. And then when I was done with my time in the Army, I was able to translate it and go right into a great role as an engineer. If you're not interested in college, there are still opportunities for you in the military. Coming right out of high school, you can do a lot of the same things, seeing the world, getting specific training that you can translate to your life after the military. So, you know, talk to your parents, talk to a guidance counselor. Maybe your high school has a junior ROTC program. Talk to those instructors if you're curious about pursuing the military. It's just something, again, that I always like to encourage, and at least just raise an awareness and just give some exposure to that for those that don't, you may not come across it every day. I spent 3 years working in a refinery after the military, and then you see I've got over 10 years with the water and wastewater business as well. I'm a little embarrassed. There's one job that I don't list on this slide. I'm a little embarrassed because there was a very short time that I worked for a company that made calendars. I got fired for taking a couple days off. If you laughed at that, go ahead and take some time to explain that to your neighbor. Rich, next slide, please. All right, so what is Engineering Week? Bradley touched on it a little bit with the proclamation from the governor. But here's some more detail to it. So it was founded in 1951. It is a national week where we celebrate some of the accomplishments of engineers throughout history. It's also a time for us to raise the awareness of the STEM education and STEM opportunities. So STEM, I'm pretty sure most of you are aware, is science, technology, engineering, mathematics. And then by raising that exposure and bringing awareness, we're hoping that we can build a strong future. We are going to need engineers in the future. We're going to need scientists and people who focus on technology, mathematics. That is a requirement for the future. And this is just one way that we can continue that and prepare for the future. Right now, we're streaming to all 55 counties across the state. And earlier this morning, there was a presentation by one of my colleagues for the elementary school and the kindergartners. So we're really trying to get out and celebrate engineers a little bit this week. So next slide, please, Rich. So there are lots of different types of engineering. You know, for example, there's Chemical engineering, I may have mentioned that before, petrochemical industry, or maybe the pharmaceutical industry. There's mechanical engineering, if you like to work with moving parts, there's car engines and pumps. That's mechanical engineering. There's electrical engineering, which is pretty obvious, but dealing with all things electric and bringing power to our homes and to various different aspects of our life that through electricity. Computer engineering, obviously very popular these days with all types of software and technology. Environmental engineering and calculating to see the impacts of our environment by human impact. And environmental engineering is very closely related to civil engineering. You see a number of pictures up here that I've tried to kind of graphically present what a civil engineer may do, what types of projects they may work on. So you see a lot of roads, you see bridges, you see tall skyscrapers. All of that was designed and constructed by engineers and all different types of construction professionals. You also see some pictures of water and wastewater, and that primarily is what at West Virginia American Water we focus on taking water. I'll just, for example, the Elk River. It's right out my back window here. We're able to filter, treat that water, disinfect that water to make sure that it can go into the pipes that I mentioned earlier. We also have some wastewater treatment plants where we take sewage that comes out of homes and businesses and schools, treat it and clean it up so that we can then put it back into streams that go back into the environment, and doing so safely, making sure that fish can still live, and that eventually people further downstream will be taking in that same river water to turn into their drinking water. So that may be kind of a gross concept if you think about it, but I want to instill confidence that at West Virginia American Water, we take our job seriously, and we make sure that our drinking water meets the highest standards. So go ahead, flip to the next slide there, Rich. Kind of feel like I may be losing my audience a little bit, this time of the presentation. So I typically would like to have some sort of interaction, but I'll kind of ask the questions, and maybe the chat will light up or something like that, and can answer questions there. But so picture yourself in chemistry class right now, and your chemistry professors start to feel sick. What would you do? Well, I hope you would try and helium. But in the rare event that you couldn't helium, I regret to say that you might have to barium. All right, so if you chuckled at those, you're probably in advanced chemistry right now, or again, you might be a good candidate to be an engineer. And that's what I'd like to talk about on this slide here, how to become an engineer. Although I don't have a bullet that talks to middle school or high school, but as Ms. Erica mentioned, taking some of those harder courses that focus on advanced mathematics, such as pre-calculus and calculus, taking chemistry and physics and biology. If you have a drafting class or a computer engineering, computer science class, those are all great opportunities to get a peek into the world of engineering to see if it's something that you're really interested in. When I talk about how to become an engineer, there's something called a professional engineer. That's really what the steps on the left of your screen outline. Being a professional engineer, you get a fancy certificate you could hang up on your wall back here. It's also pictured on the right side of your screen. And you get a fancy stamp that's in the middle of the screen as well. And what that professional engineer really does is that they're the final check, and they give their seal, their stamp of approval that what has been designed is safe for construction, that it's sound, and that it can be built and it can be operated safely. So if you're a professional engineer, you are that last check to make sure that something is safe before it's built. So going back to how you become an engineer, the first step is to attend an accredited university. And by accredited, I mean, there are certain requirements that professional engineering review have. certain classes that you'll have to take, certain opportunities that you have to be exposed to engineering. Most of your state universities, your four-year state universities, are accredited for all types of engineering. So if you attend one of the larger state universities, you'll check that block. Towards the end of your time in college, your senior year, you'll have to take an 8-hour closed book exam called the Fundamentals of Engineering exam. You do get to bring one book in. I know I say closed book, but it's a book with all of your engineering formulas, but it's still an 8-hour exam. You take it usually in the spring of your senior year. The last thing on your mind and what you want to be doing is taking the test. But again, your senior year of college, you're forced to take an 8-hour exam. After you're done with college, you have to obtain 4 years of engineering experience. That's typically, with an engineering firm or a construction company, and you'll probably work under a professional engineer, kind of as an assistant, as a project engineer. And there you'll pick up some of the field practice of what engineering actually looks like in the real world, right? It's not just a bunch of books and studies. Here's actual 4 years of application of engineering. And after those 4 years, you fill out some paperwork, you pay a couple fees, and you can take another 8-hour exam. This is probably not a great recruiting tool to be an engineer. I apologize, but it's the truth. Another 8-hour exam. Now this one is open book, and when I took my exam, I had to. I had one of those suitcases on wheels. I brought in all of my engineering reference books and things like that, and you can flip through them. I tabbed them and had it all during the exam. But thankfully, I passed that exam as well. And once you're done with that, you take a commitment to the ethical practice of engineering. By that, I mean you want an engineer to be trustworthy. You want them to be someone that is a moral person, is not going to seek for selfish gain or political, sides of things. So that's why there's also an ethical commitment. Actually, every year I have to take 1 year of every year I have to take 1 hour, not 1 year of training, 1 hour of ethics training. Again, just to keep me and other professional engineers up to date on current practices and legal issues that are out there regarding engineering. So again, probably not a great recruiting tool, but as Ms. Erica said, doing hard things, I think, what you sow is what you reap. And if you work hard, I think you're really going to see a great reward. So I think, Rich and Bradley, that's all I had. I wonder if there are any questions out there that came in the chat.
We do, Mike. We have actually several questions for you. I'll go ahead and start. Your joke, we have a comment, your joke was genius. But we'll go ahead and jump in. We have several really great questions. First, what can a high school student do to prepare for an engineering major? Does being in robotics, example, a robotics team help? I know you mentioned that a little bit, but is there anything you'd like to add to that?
Totally. And so being in robotics, right? Yes, that's a benefit, but if you're not in robotics, it doesn't mean that you can't be an engineering student in college. Let me take a step back from robotics. So if you're interested in robotics, you may not be able to be a part of a club, but just that interest and how your mind works of wanting to understand how and why things function. What happens to the robot if I change this, if I change this gear, if I change the power source, all different types of things that may go into robotics. That mindset, if you're curious about that, I think that is a great recognition of, maybe you do want to pursue a career in engineering, because that's what it starts with, is that curiosity. Engineers may have a reputation of being pretty boring, kind of, predictable type people, but really when you look at and when you talk with an engineer, you're going to find someone who's very creative, because as an engineer, you're a problem solver, and every problem requires a different approach, probably have a different solution. So as an engineer, you're bringing that creativity, but also the technical expertise to hopefully solve and tackle that problem. So in high school, robotics, any type of club that deals with that is obviously important. It doesn't always have to be about being in the classroom. I would love going out in my backyard, and I used to build forts as a kid, right? And I play Army, right? So that probably says a lot about, kind of my career path, but just building stuff on your own, if it's something, Legos, my kids love Legos. I hate stepping on them, but kids love playing with Legos. It's just, small things like that are going to point you towards that career in engineering.
That's great, Mike. Thanks so much. But we have another one. What was the most unexpected part of being an engineering major for you?
It's a lot of hard work. I kind of expected that. I think one thing that I didn't expect is writing side of it. Engineers are not known for being, good writers. But the fact that I'm here right now, speaking publicly, having to prepare some notes, and then how to communicate, what I love about engineering, it does require you to write as well. And writing was not something that I loved to do as a kid, right? I've talked about everything I loved doing as a kid, right, that pushed me towards engineering. Well, I didn't love it writing, and that's probably why I went into science and math. But there is an aspect to engineering that's going to require you to be, well versed in writing and grammar and public speaking, and that's something that I really didn't even think about going into the engineering field. But I think what it does highlight, though, to brag a little bit, is as an engineer, you need to be a well-rounded person. You can't just focus on one certain thing. You really need to focus on being well-rounded and just looking at all the things around you, not just being focused on one small problem or solution that you're working on.
Thank you, Mike. We have a comment. The calendar joke was great, but the helium joke went over my head. So that was a good one. We have another
That's
question.
actually, that's a future engineer right there.
The helium going over your head, I love it.
We have another question. As a civil engineer, what motivated you when you were a student?
I always wanted to build a bridge. So I was actually born in Brooklyn, New York, believe it or not. My father was in the military. He was stationed in New York City at the time, a place called Fort Hamilton. And I was born literally in a hospital. It's right near the Verrazano Narrows Bridge. And I kind of attribute that to my lifelong affinity and just attraction to bridges. I love bridges. Then I got to college and I took an advanced structural analysis class where we had global stiffness matrices. And that's when I realized that as much as I love bridges and looking at them, maybe I'm not cut out to build them. So, just because you focus on one path of engineering, you can change. And not to say that water and wastewater is easier or less important or less hard than structural engineering. It's just I gravitated towards that in college. It's where I didn't want to pursue building bridge anymore because all of a sudden water and wastewater just seemed more appealing to me. So that's how I kind of transitioned to that area of engineering. But I think that, as a young age, you're going to see and just know that your curiosity, right, is going to be piqued at certain things. Certain teachers are going to influence you. For me, it was a chemistry professor when I was in college at West Point, New York, who really kind of just opened, I looked at chemistry different. Even though I took it in high school, when I got to college, it looked different to me. It felt differently, and I was just more excited about it. And that's when I started to realize that the chemistry involved in water treatment is just something that I want to pursue more. So look for those small encounters in high school and your middle school that are going to help point you towards, whatever career it is you may want to be. You can say the same thing about the medical field. I don't know about lawyers, but
All right, and as we wrap up here, one question, and I'm going to add something to the end. The question is, do you use technology in your job? And I might add to that, how have you seen technology change in engineering or integrated more into engineering? So great question and kind of already a follow-up to that, but I'm just curious how you've seen technology kind of develop and integrate more into your engineering practices.
How much time do we have, Bradley? Right? I mean, this is
4
just
minutes.
it's been incredible.
Yeah, it's been incredible. So technology in the field of engineering, right? So, okay, calculators. Right? Okay, let's put calculators aside. And so part of my engineering team, I have 18 in my engineering department. 4 of them are focused on mapping, GIS, geospatial information systems. And what they do is they help build maps of our utility system. So all of the 4,600 miles of pipe that I talked about before, we have on a map. And we have all the valves, all the fire hydrants, all of the water tanks that are attached to those pipes. They're all depicted on a map. Well, that requires you to have your GPS, right? So on our phones there, we all have GPS and trackers and maps and things like that. Well, my GIS team uses technology to be very, very precise, because when one of our operators needs to go check a fire hydrant, turn a water valve, I don't want them wasting time walking around looking for this valve that's perhaps under a couple inches of snow. I want them to be able to pull up their utility map and see that, okay, on the corner of, Smith and Green Street, I can go find the water valve and turn that water valve for whatever reason. So I think mapping is an area that has been just huge lately with technology. And one more, if I can, Bradley. There's a lot of, water in pipes is under pressure, right? So there's all of the hills across West Virginia. We have to introduce energy through pumps to lift the water, comes down the hill, lift it up the next hill, right, to get it to everyone's home. And that requires, there's pressure. Those pipes are under pressure. And because of that, we can put monitors and sensors on our pipes, specifically on some of our valves and some of our hydrants and on water meters, to measure that pressure, to make sure that the pressure on that pipe, of water inside that pipe, is stable. Because if we have spikes in pressure, that's when you'll start to see water pipes breaking, because they're designed to be able to hold a certain amount of water that's under a certain pressure. But when that pressure exceeds that limit, that water pipe may break. One of the seals may blow, just like anything that's mechanical. So we've been incorporating across the state these small sensors and monitors that measure the pressure, because the more stable we can keep that pressure, the more reliable the water service is going to be. So as we put these monitors on, these sensors, and they have these spikes, I'll go to my operator and say, hey, why was there a spike, last week in the system? When I look at the report, he says, oh, there was a house that was on fire, and the fire department had to open and close the fire hydrants. When you do that, and you take a lot of water out of the system, and then all of a sudden you stop, it creates this surge and this drop in pressure. So I realized, wow, every time that we have a fire event and the fire department needs to open up a fire hydrant, they're introducing a change in the constant pressure that I'm trying to maintain in our system. So it wasn't, conceptually I knew about that, but it wasn't until that we started looking at these sensors and placing them on our pipes, and then looking at the reports. So what are we going to do to counteract that? We can introduce all kinds of different technology and surge protection to help dampen that surge in pressure. So I'm sorry I'm getting a little bit technical, but just the technology, I think, is really allowing us to make our system more reliable. And those are just 2 examples, Bradley, between the mapping and then pressure management system of how technology is making all of our lives better, really, in the water industry.
I think that's great, Mike, and I really appreciate you taking time, and what a great presentation. I know really interactive and some great questions from students. And again, thank you so much for being part of this with us today. And Erica, we really appreciate you and the Department of Education for West Virginia and our partnership on STEM education as we continue to educate our young leaders on careers in water and wastewater industry, and specifically this week in engineering. And with that, I will give you back the rest of your day, and really appreciate all those tuning in today. And as always, it's our honor to help keep life flowing here at West Virginia American Water. Have a great day.
Hey, Bradley, can I